Hello dear student, I am Varun Nishant from LPM school. In this video, we will talk about the homologous series. Homologous. As you know that a series of compounds in which the same functional group substitutes for hydrogen in a carbon chain. That we call homologous series. Homologous series. Homologous series, a series of compound in which the same functional group substitutes for hydrogen in the carbon chain. That we call homologous series. Just we understand with the help of example. So, example alkanes. These are the hydrocarbons which contain, and the simple formula of the alkane, which is CnH2n plus 2. CnH2n plus 2, very simple, and if that CH4, C and C2H6, C3H10, because like that, if the value is C3 plus H2, 3 plus 2, here is 3 plus 6, here is 8, I'm very sorry, there is 8. Now, so value is 6 plus 2, which is equal to 3 and 8. 3 and 8. And C4, if the value is C4, then it will be equal to, if the put the value of 4 here, and it will be 8. C4H10. So these are the alkenes. Now alkenes. Which is the common formula is Cn and H2n. These are the alkenes. So CH3. If we write C2H, if the 2, let's put the value C2H4. Now C3H6, C3, writing manner, in regular manner. Here is C3, H6. Here is C4, H8. Now, another is, I am writing on this side. So, alkenes common formula is Cn and 2HN. H2N. Now, the alkynes. Alkynes which is formula is 2CnH2n minus 2. So now it is write as CH. If it is C2 and it will be hydrogen as C2 means 2 plus 2n2 minus 2. So 2 plus 2 to the 4 minus 2. So 2 plus 2 means C2H2. C2H2. Now C2, C3. C3 and right here C3, 6 and remaining is 4. C3H4. C3H4. And now C4. C4. Now here is C4. 8 minus 2 become 6. So hydrogen number of hydrogen is 6. So in this homologous series of different alkane, alkenes, alkynes, if you pay attention on here, there is a Ch-4, methane. If you move from one to another, if you add in this CH4 the 2, it will become CH3 and H6. The difference on them, which is CH2. CH2 and another difference CH2, another which is CH2. In other way, you can prove that it is right or not. So take example. Take example of methane. So methane CH4. If you add into this CH2, add this CH2, it will become C2H6, which is that. So the difference between these compound, which is methane and ethane, these are the difference between methane and ethane, which is CH2. So on this compound, the main difference between them is CH2. So these are the similar to each other because they are only difference between CH2. On this side, so these are the difference between these are the alkenes and alkynes. Now let's do the activity. Which is activity in between to understand the homologous series of carbon and its compound, which is that calculate the difference in the formula of molecular masses. For calculate the difference. So our activity is calculate the difference of the formula and molecular masses. Calculate the difference in the formula formula and molecular masses for methyl alcohol CH3OH and A, which is A and methyl alcohol and ethyl alcohol C2H5OH and B C2H5OH and H7OH and C is C3H7OH and C4H9OH. So these are the carbon compound, and make a difference between these compound formula and molecular masses. Now let us see. Take the methyl alcohol and ethyl alcohol CH3OH C2H5OH. If we take the molecular formula, which is molecular mass of this carbon one carbon, atomic weight is 12 and plus 3 hydrogen, as it is the hydrogen atomic mass is 1, so I will write here 3 and oxygen 16 plus 1, because one hydrogen here is C2H5OH, 12 into 2 plus 1, 5 plus 16 plus 1. So it will be right as 12, 24 plus 5 plus 17, and it will be right as 7, 5, 4, 7 plus 5 plus 4 is equal to 11, 1, 1, 2, 3 plus 1, 4, 41. So, and now take here the molecular mass 12 plus 3 15 plus 1 17 and the weight on this side 1 6 7 3 10 2 12 2 1 area and then 1 1 2 1 3. If you calculate this A, B and C groups of alcohols which contain this and this and this, so these group of alcohols represent the of CH2. If you compare from this A and if you compare this B and if you compare from this A, the main differences are between the CH2. Now in this alcoholic groups from increasing order, we can conclude that these are the homologous series. These are the homologous series, because they are in increasing order, but groups are eventually same if that the mass varies at a time, but the groups are same.